Hey, math peeps. So in today's lesson, we're going to continue our conversation around solving quadratic equations, but we're going to turn our attention to factoring. Now, I'm hoping today's lesson is actually going to be fairly easy for you because we have dealt with factoring in a few different scenarios already. 10C factoring was introduced to you. You spent a long time in 10C reviewing and practicing factoring. And whoever your 10C teacher was, hopefully they kept drilling into you that factoring is one of the most important things you can learn to be successful in 10, 11, and 12 math, okay? But even in 20-1 so far, we have factored quadratics already. We reviewed it, but then we also looked at how the factor connects to the x-intercepts. We talked about something called the zero product principle. If a number times a number equals 0, then one of those numbers has to be 0. So if a factor times a factor equals 0, each of those factors can be set to 0 and we can solve from there. That's all we're doing today, okay? There's no difference now in our solving lesson today. So I'm hoping it'll go quick, it'll go easy for you. But if it doesn't, you need to make sure you're doing lots and lots of practicing, okay? Okay, so here we go. I'm just going to hide my face while I read the question. Solve the following equations by factoring. Verify your answer by graphing and finding the zeros. And that's what we did yesterday in our work. Okay, so here is the first example. X squared minus 7x minus 30. Now, what am I looking for? Well, in order to factor, I'm looking for two numbers that multiply together to give me those outside numbers together. Okay, so two numbers that multiply together to give me negative 30. And add together to give me negative 7. Now, if I don't know them, that's okay. I'm just going to start by writing my factors of 30 down. So 1 and 30. That's not going to get a 7. 2 and 15. That's not going to get a 7. 3 and 10. Oh, look, that one will get a 7. Remember, one of my numbers has to be negative. So if I put a negative on the 10 there, I can see that 3 plus negative 10 will be negative 7. And I can see that 3 times negative 10 will give me negative 30. So those are going to be the two numbers that will make this process nice and friendly for me, okay? So I'm going to go straight to my answer here because this is what we would call a shortcuttable one when the coefficient in the front is 1. If you want to go through decomposition first, if you want to break that negative 7 down into the negative 10 and the 3, the negative 10x and the 3x, and then factor the front two, factor the back two, by all means, please do that, okay? You'll still arrive at the same answer. Either way, your answer should be x minus 10, x plus 3. X minus 10, x plus 3. Now, that's a factor times a factor equals 0. Each of those factors could be my 0. So now I separate it into two separate conversations. Either my x minus 10 could be my 0, or my x plus 3 could be my 0. And now I solve for each one of them. So if x minus 10 is 0, x will equal 10. I just added 10 to both sides. And if x plus 3 equals 0, I'll have to subtract 3 from both sides, so x will equal negative 3. So I have two solutions, negative 3 and 10. So I conclude there with x equals negative 3 and 10. Now, to verify, go ahead and graph it and see if you can calculate the zeros, okay? Of course, you're pausing me all the way through this to try it yourself. Remember, everything's easy when you just see the answer appear, right? Okay, so your graph should look like this, and do take note, the x-intercepts were at negative 3 and at 10, so I've graphically verified it as well. All right, easy peasy. Number 1 down, only a couple more to go. You can do this, you can handle factoring. Factoring will become your most favorite F word in math. You know, next to fractions and functions and okay, 2x squared plus 5x minus 3 equals 0 is the next one. Okay, so again, I'm looking for two numbers that multiply together to give me negative 6 this time, 2 times negative 3, and add together to give me 5. So I go through my factors of 6, so 1 and 6, 2 and 3. Okay, if I want to multiply to be a negative, 1 has to be negative. So that's actually going to be the 1 and 6 pair. If I make this 1 here negative, negative 1 plus 6 will give me positive 5. Negative 1 times 6 will give me 6. So here is an example where I am going to walk you through decomposition because this is not shortcuttable. Again, though, if you're comfortable with what you would call inspection and you can go straight to the answer, totally fine. So I broke my 5x into 6x and minus x. I'm going to factor the front two. I can take out a 2x from the front two. And that would leave me with x plus 3. Then I'm going to take out a -1 from the back two. And that would leave me with x plus 3. Okay, so now I can see that my x plus 3 is common to both of these terms. I can pull out the x plus 3. I'll have x plus 3 times 2x minus 1. So there is my zero product principle. I have a factor times a factor equals 0. Each of those factors could be my 0, so I set each of them to 0 and solve. If x plus 3 equals 0, I'll have to subtract 3 from both sides, and I get x equals -3. There's 2 steps here. Just be careful on this one. If 2x minus 1 equals 0, I'll add 1 to both sides. That'll give me 2x equals 1. Then divide by 2. So x actually equals 1/2. So my solutions here will be x equals -3 and 1/2. Go ahead, grab your graphing calculator, verify this by either putting y2 as 0 or by calculating your x-intercepts. Okay, so the picture you should have gotten looks like that. And again, we can see I've got an x-intercept at -3 and at 1/2 there, 0.5. Okay. Awesome. Okay, 4t squared minus 81. Now this one's a little different because there's only 2 terms. Don't forget the equal 0. I didn't say equal 0. You always have to have an equal 0 there, okay? I see this as a difference of squares, okay? So I can see that this factor is a squared minus b squared equals a plus b, a minus b. Okay, do you remember that property? So the square root of 4t squared would be 2t, and the square root of 81 would be 9. So I'll have 2t plus 9 and 2t minus 9. There's a zero product principle. I have a factor times a factor equals 0. Each of those factors could be 0. So I'm going to pull them out. If 2t plus 9 equals 0, I'll subtract 9 from both sides and divide by 2. So that'll be t equals -9/2. And then if 2t minus 9 equals 0, I'll add 9 to both sides and divide by 2. So I end up with t equals plus or minus 9/2. Okay, go ahead and graph that so you can verify. 9/2 is like 4.5. So on your graphing calculator, that's what you should see. Okay, and here's a picture. And it is in fact what we see. We see an x-intercept at -4.5 and at 4.5. So there are 2 solutions to this equation, -4.5 and 4.5. Those are the only 2 numbers that if I was to plug them back in for x, I would get out a true statement. I would actually get it to equal 0. Every other value for x will not give me 0. That's what a solution means, okay? Okay. Last little factoring one, 5w minus 3w squared equals 0. Now this is 2 terms and there's not a difference of squares, but there is a common factor, okay? W is common to both of these. So we can just pull the w out as the greatest common factor. That's going to give me w, and what's left is 5 minus 3w. So I have w times 5 minus 3w equals 0. Well, guys, that is a zero product principle. Just because this doesn't have 2 terms in it doesn't mean it's its own factor. So I'm looking at that times that equals 0. Either one of those could be my 0. Okay, so I've got w equals 0, and that one's actually done. There's nothing else to solve there. Or my other factor equals 0. 5 minus 3w equals 0. Okay, so w equals 0 is all done, but 5 minus 3w, I could bring my -3w over to be positive 3w and then divide by 3. So I'd end up with w is 5/3. Okay, and again, I did that by taking my -3w, I brought it over here, so it was positive 3w, and then I just divided both sides by 3. Okay. Okay, so I've got right now, w is 0 and 5/3. Go ahead, grab your graphing calculator, just like we did yesterday. Plug that original equation in and verify that you're going to get 0 and 5/3 as the x-intercepts. Okay, again, either y2 is 0 and you're solving for the intersection points, or if you have a Casio, you can solve for the root. Okay, the picture you should have gotten was this. And again, we can see 0 and 1.66666, which is the decimal approximation of 5/3. Okay? Easy. We got this. You just have to be comfortable with factoring. Okay? Okay. If you are unable to factor the equation, how could you work backwards from the x-intercepts of the graph to determine the factors? We've actually done this before in some of our other homework questions where I've asked you to build me an equation, okay? Given the x-intercepts, build me an equation for whatever, okay? That's what we're gonna do here, okay? So let's just pick some numbers. So we set each intercept equal to 0, and that will give us our factors. That's what we're going to do here. I'm just going to hide my face for a quick sec so those of you at home can see that full question, because I'm probably blocking a bit of that. Okay, so as an example, I'm just going to pick some. We are going to build an equation that has solutions of x equals 3/2 and 5. So in the final step of the factoring questions that I would have done, I would have gotten a statement that says x equals 3/2 and a statement that says x equals 5, okay? Well, if this said x equals 3/2, it had to have said something equals 0 in order for me to get to x equals 3/2, okay? And it's that something that's actually the factor that I'm looking for. So I'm just gonna do the reverse process, okay? If I wanna get rid of the division of 2, I'll multiply both sides by 2. That'll give me 2x equals 3. Right? Let me just write that. 2x equals 3. That's me just multiplying both sides by 2. But then if I wanted to equal 0, I'd subtract 3 from both sides. So I'd end up with 2x minus 3 equals 0. That is a factor that I'm going to use in my equation. Okay? So it's going to be 2x minus 3 times something. Okay? Well, the something comes from this guy. If x equals 5, I'll bring that 5 over so it equals 0 and get x minus 5. So I end up with an equation that reads 0 equals 2x minus 3 times x minus 5. Or if I wanted to multiply that out, I'd have 2x squared, like first outside, inside, last, right? 2x squared, this would be negative 10x, negative 3x. So when I combine those, that would be negative 13x and then plus 15. Okay, so I could also say that it's the solution to 0 equals 2x squared minus 13x plus 15. I have built an equation right here that this and this are the only two solutions to that equation, okay? If I plug either one of those in, I will get a true statement. I will get out 0. Any other x value that I plug into that equation will not work. 3/2 and x equals 5 are the only solutions. They would also visually be the x-intercepts of this quadratic, okay? See, I told you today was easy. All right, so here is your homework for the day. Make sure you're using your time wisely and doing as much of this as possible. The more practicing you can do, right? Everything's easy when you watch me do it. The more practicing you can do, the better you'll be prepared, okay? Tomorrow is something very new. I'm going to teach you the quadratic formula, which is a way to get to solutions that are exact value solutions when we can't factor the equation, okay? But I know that's going to keep you up tonight because you're so excited about tomorrow. Today, I need you to focus on the factoring, okay? The factoring is so important. Factoring is always kind of your first algebraic go-to in all of these sorts of questions, okay? So there's your homework. And if you have any questions, you know where to find me. You guys got this. You rock. Take care.